This is the first video to prove why the sum of the angles in a triangle equals 180 degrees. Everyone has seen this and even used it at some point, but never wondered where this statement comes from. Many teachers leave this out to simplify the lesson. It's very interesting and simple, yet it makes a huge difference when solving problems involving angles. Take any triangle. If you add up its three angles, the sum will always be the same. 180 degrees notat, no matter what cozzata. Straight, slanted, or partially closed, it always adds up to the same thing. First, we need to start with an axiom, which is a statement so true and obvious that it requires no proof, universally accepted by all mathematicians. The axiom states that given two parallel lines, that is, these two lines are parallel, this line here is what we call a transversal line, and also, this transversal line forms corresponding angles. What are those? It means that this little angle here, this angle, will be exactly equal to this angle here. To put it another way, the slope of this white line is exactly equal to the value of that slope over there. In other words, the absolute truth is that if I have two lines that are parallel to each other, and I have another line that intersects them, it always forms corresponding angles. It would be this angle here, look, it will be exactly equal to this angle here. They are corresponding angles. This here is the absolute truth that we start from to prove our claim. Another obvious but important point is that if I have a straight line, that's a 180-degree angle. It represents a half turn, and it's always possible to divide this angle into three parts, as in this example appearing on your screen. So, to begin our demonstration, let's draw two parallel lines. Then we draw two transversals to them, but in such a way that the second transversal passes exactly through the point where the first one already passed. The transversals must pass through this point, as this forms an arbitrary triangle. If we prove that these triangles' angles add up to 180 degrees, it means every triangle will too. We choose to draw it this way because it allows us to form corresponding angles. This angle A moves up here, just as this angle B also moves here due to the same property. Another theorem, a statement we use here, is the fact that vertically opposite angles are equal. Essentially, we have two straight lines that intersect to form an X shape, which ensures that the two angles at the top and bottom are of the exact same measure. This fact automatically implies that this specific angle C drops down into our triangle. Consequently, this resulting triangle now contains the three angles A, B, and C. And look, these three angles together form a perfect half turn, because A plus B plus C equals 180 degrees. Look how beautiful that is, everyone. We have proven in a simple way that the sum of the three interior angles of a triangle really does equal 180 degrees, and we understand where this statement comes from. We can use this as an example to find the value of angle x. We already know that the sum of the three angles is a 180, so we set up this simple equation. It will be 50 plus 40 plus x equals 180. Adding them up, we get 90 plus x. Subtracting 90 from both sides, we get that x equals 90 degrees. It's a simple example, but one that makes the importance of this statement clear. Did you like the video? Consider clicking the subscribe button. I'm Professor Vittorio Augusto, and it was a pleasure having you here with me. Click on the card appearing on your screen and see how I solved the hardest problem of my life.